first term, D is the common difference, and N is the number of terms or order of terms. Let's have the following example. First, we have to determine the last term or the nth term of the sequence. Example, what is the 10th term of the arithmetic sequence 5, 12, 19, 26, and so on? First step, we are going to find what is asked in the problem. The problem is asked for the 10th term. And what are the given? Great! The given are a sub 1 is 5, n or the number of terms is 10. Why 10? Because you are asked to find for the 10th term of the sequence. And D or the common difference is 7. Why? It's because the difference between any two consecutive terms is 7. What is the equation to be used in solving the problem? Exactly. The equation to be used is the rule of an arithmetic sequence, which is a sub n equals a sub 1 plus the quantity of n minus 1 times d. Next step, you are going to substitute the value of each variable. We have to replace a sub 1 by 5, n by 10, and d by 7. Therefore, a sub 10 equals 5 plus the quantity of 10 minus 1 times 7. After the values are substituted in each variable, next step is to apply the PEMDAS rule. So, we have to simplify first the numbers inside the parentheses, and the equation will become a sub 10 equals 5 plus the quantity of 9 times 7. Next, multiply 9 and 7. The equation will become a sub 10 equals 5 plus 63. 5 plus 63 is 68. So, the 10th term of the given arithmetic sequence is 68. The next example focuses on how to determine the first term of an arithmetic sequence. Example, what is the first term of the arithmetic sequence given that a sub 6 equals negative 17 and the common difference is negative 3? What is asked in the problem? Very good. You are asked to find for the first term of a sequence or a sub 1. And what are the given? Correct. The given are a sub 6 equals negative 17, n equals 6, and d equals negative 3. What is the equation to be used? Exactly. The equation to be used is a sub n equals a sub 1 plus the quantity of n minus 1 times d. Next step is to apply property of substitution. You have to substitute the value of each variable in the given equation. Negative 17 equals a sub 1 plus the quantity of 6 minus 1 times negative 3. Next is to apply the PEMDAS rule. Simplify first the number inside the parentheses. The equation will become negative 17 equals a sub 1 plus the quantity of 5 times negative 3. Next, multiply 5 and negative 3. We have negative 17 equals a sub 1 plus the quantity of negative 15. Next is to apply addition property of equality. We are going to add both sides of the equation by 15. We have negative 17 plus 15 equals a sub 1 plus the quantity of negative 15 plus 15. Simplify. The equation will become negative 2 equals a sub 1 or a sub 1 equals negative 2. Therefore, The first term is negative 2. The third example shows how to determine the common difference of a sequence. The first term of the sequence is 2, while the 18th term is 87. Find the common difference of the sequence. Step 1. What is being asked? Correct. You are asked to find for the common difference of the sequence. Step 2. What are the given? Very good. The given are the first term or a sub 1 is 2. The last term or a sub 18 is 87. And the number of terms is 18. It refers to the order of the last term. The same with the previous examples. This problem can be solved by using the formula a sub n equals a sub 1 plus the quantity of n minus 1 times d. Next, substitute the given values in the formula. So, the equation will become 87 equals 2 plus the quantity of 18 minus 1 times d. Next, apply the PEMDAS rule. Simplify 18 minus 1. The answer is 17. So we have 87 equals 2 plus 17d. We have to eliminate 2. So what will you do? Great! We will apply subtraction property of equality. Just subtract both sides of the equation by 2. 87 minus 2 equals 2 minus 2 plus 17d. Simplify. 87 minus 2 is 85 equals 2 minus 2 is 0. And then bring down 17d. Next, apply division property of equality to eliminate the coefficient of 17d. 85 divided by 17 equals 17d divided by 17. Simplify. Therefore, the common difference is 5. Let's have the last example. It focuses on how to determine the number of terms that an arithmetic sequence has, which is also pertains to the order of certain term. Example, determine which term of the arithmetic sequence, negative 7, negative 11, negative 15, and so on, is negative 39. Step 1. What is being asked? You are asked to determine the number of terms in a sequence or the position of the last term. It also refers to the terms that a sequence has. Step 2. What are the given? Correct. The given are a sub 1, which is negative 7, a sub n, or what we call the last term, is negative 39. And the common difference is negative 4. Because the difference between any two consecutive terms is negative 4. Step 3. What is the equation or the formula to be used? Very good. The formula to be used is a sub n equals a sub 1 plus the quantity of n minus 1 times d. Step 4. Substitute the value of each variable in the given formula. Replace a sub n by negative 39, a sub 1 by negative 7, and d by negative 4. So, we have negative 39 equals negative 7 plus the quantity of n minus 1 times negative 4. Simplify. The quantity of n minus 1 times negative 4 by applying distributive property. Bring down negative 39 equals negative 7 plus n times negative 4 is negative 4n, and negative 1 times negative 4 is positive 4. Negative 39 equals negative 7 minus 4n plus 4. Next, simplify the expression on the right side. The equation will become negative 39 equals negative 3 minus 4n. Apply addition property of equality. Add both sides of the equation by 3. So, we have negative 39 plus 3 equals negative 3 plus 3 minus 4n. Simplify. Negative 39 plus 3 is equal to negative 36 equals negative 3 plus 3 is 0. And then, bring down negative 4n. Negative 36 equals negative 4n. Next, eliminate the coefficient of negative 4n by applying division property of equality. Divide both sides of the equation by negative 4. Negative 36 divided by negative 4 equals negative 4n divided by negative 4. Negative 36 divided by negative 4 is 9, and negative 4n divided by negative 4 is n. Therefore, negative 39 is on the 9th term. Thank you for watching. I hope you learned something from today's lesson. I am Teacher Jonald, and see you in the next session.